This is the notes for Unit 11, Combining Rules of Exponents. We're going to take all of the individual rules that we learned yesterday and then use different properties and combine them within the same problem. Okay, so I'm going to start by writing mine in expanded form. So 7x squared y would mean 7 times x times y. And then we're also timesing that by negative 3 times x times y to the third power. So that's y times y times y. Okay, so the first thing I need to do is simply multiply my coefficients. So my numbers out in front do not have an exponent with them, so I can just do 7 times negative 3 is negative 21. Okay, there's nothing special, it's just negative times a positive is a negative, and then 7 times 3 is 21. It's not till I get to something with an exponent that I combine my rules. Okay, so x squared, and then I have another x over here, so I can add a 1 if that helps you. But I can combine those and say x squared times x to the first power makes x to the third. I had 2 plus 1 would give me 3 x's. Same thing with my y. I had 1 y, and then over here y to the third. So altogether, I'm going to end up with y to the fourth. Okay, so my rules for exponents are I add. When I'm multiplying things with the same base, I add their exponents. That number out in front, though, my coefficient still just stayed. So this is my final answer. I cannot put in x with a y and have a final answer to the 7th power. Okay, I'm going to leave it as my x's and my y's. If your answer is in alphabetical order, that'll help you eliminate some errors of having duplicates. Okay, but my final answer, I do have to leave x and y separate. So another one just like that. So I have negative 10 times x to the third is x times x times x. Times negative 2 times x times y. So my numbers in front, those coefficients, negative 10 and negative 2 get multiplied together because they're normal numbers. A negative times a negative is a positive. So I would have a positive 20. And then I have x to the third with 1x over here. So my rules of exponents say to add the exponents. I have 3 with another one plus 1, would all together in my list give me x to the fourth. I only have, though, 1y, so I can write y to the first or leave that as just y. Again, my final answer should be in alphabetical order. So an x and then y, and I combined my x's with my x's, my y's with my y's. Those numbers out in front just get multiplied. All right, this next one, we're going to add one more step. So before we start, I have 2n squared. This square up here means that I have this whole thing happening twice. So 3 squared, 3 times 3 would be 9. N squared, so n times n. And then m to the third, and that's got squared. So I had 3 m's and 3 m's, makes m to the 6th. My rule was I take everything in here, squared, and then I multiply anything that already had an exponent. So I had n to the first happening twice, so 1 times 2, and then n to the third happening twice, so that gives me m to the 6th. Okay, I can also write this out in expanded form. So 2 times n, that's 2n squared. And then I have 3 times n times m, m, and that whole thing happened twice. So 3n, m, m. So now I'm looking to simplify my coefficients, those numbers out in front. I have 2 times 3 squared. 3 times 3 was 9. So 2 times 9 makes 18. 2 times 3 times 3. Those are all my numbers out in front. And then my n's. I have n squared, and over here, n squared again. So inside those parentheses, n happened twice, and over here I also had n squared. So 2 plus 1 would give me 4 n's. Or I can also look up here, n squared and n squared would also make n to the fourth. I'm adding all of my n's in that big list. I can rewrite this in alphabetical order, and then I'd have all 4 n's. And then I would have a total of 6 m's. So m to the third happening twice would make m to the 6th, just like how it looked up there as well. Okay, so that's my final answer. All right, I can't combine my n's with my m's, so I'm going to leave those separately. But I could do the whole numbers out in front multiplied by each other. My exponents I'm simply adding to figure out how many total are in my list. Okay, so let's do that same thing here. So 2y to the 5th, that's happening 3 times. So 2 to the 3rd power is going to be 8. And then y to the 5th, y to the 5th, y to the 5th would make y to the 15th. I would still multiply that by x, y to the 8th. Okay, so if you want to write that in all expanded form, 2 times 1, 2, 3, 4, 5 y's. 2, 1, 2, 3, 4, 5 y's. 2, 1, 2, 3, 4, 5 y's. So that whole thing happened 3 times. And then I also had x times 8 y's. 7, 8. Okay, so you'll notice it gets really long. If you're starting to pick up on the rules, feel free. You don't have to write out this whole expanded form, but I would at least copy this. Okay, so we're looking for that first one. 2 to the 3rd means 2 times 2 times 2. So 2 times 2 is 4, times 2 would be 8. I do know what that answer is, so I can go ahead and simplify it. Also, don't get it lost in the list, I had one x, so in alphabetical I'll have x there first. And then I have a lot of y's. So I have y to the 5th happening 3 times. We said that made y to the 15th. And then I had another 8 y's over here. So in my final answer, I have 15 plus 8 will make y to the 23rd. Okay, so again, that's a huge answer in expanded form. Okay, so feel free for your work, go ahead and just write this. So we distributed this exponent with a 3, became 2 to the 3rd, and then 5 times 3 would make y to the 15th. And then my second rule was I combined my y with my y by simply adding the exponents. So in this huge list, I could rearrange 2 times 2 times 2 to make 8. I had one x, and then I had 5 y's, 5 y's, 5 y's, 8 y's. All together, I can add them up and say y to the 23rd. Okay? If you don't understand how I got from here to here, please go ahead and write it out in expanded form. 2 times y to the 5th, that whole thing happening 3 times. Okay, we got 2 more. All right, I'm looking for m to the 5th, p to the 4th, and then this is in parentheses, so this is happening multiple times. So m to the 3rd squared, I'm going to leave this guy alone, would mean m to the 6th, p to the 12th. So 3 2 times would make 6, 6 2 times would make 12. If I write this out in expanded form, slide down there, Selmer, I would have m to the 5th over p to the 4th, and then I have m to the 3rd, p to the 6th, happening twice. Okay, so altogether, m to the 3rd happening twice would make m to the 6th for your shortcut. P to the 6th, in that parentheses, the whole thing happened twice. We would do 6 times 2 and I would get 12 p's. For my final answer, I want to combine all my m's. So I have 5 m's plus 3 would give me m to the 11th. On the bottom, I have 4 plus 6 plus 6. So altogether, 4 plus 12, p to the 16th. That is my final answer. I can't do anything further because I don't know what m is and I don't know what p is. So I'm simply combining all my like terms. I had m 5 times and then 6 times after I squared it. On the bottom, we had p 4 times, and then we had 6 of them happening twice to make 12. So altogether, I have m to the 11th, p to the 16th. Okay, one more. We have m to the 5th, 2, 3, 4, 5, with a b, and on the bottom, an m and a b. So the last rule we haven't talked about is if they're a fraction, I subtract my exponents. Okay, so when they were in a long list, I could add them up because they were all together. If they were in parentheses, we took them times each other because I had the 5th happening 3 times, so 5 times 3. If they're a fraction, though, they're simply going to cancel each other out. So with my m's, I had 5 on top with 1 on the bottom. So you can add the 1 there if that helps you. 5 minus 1 would leave me with m to the 4th. For my b's, I had 1 on the top, 1 on the bottom, so there's actually nothing left. I could write b to the 0, but that just means 1. Okay, so I could say my final answer then is just m to the 4th power. Anything to the 0 is 1, so you don't have to write that down. They cancel each other out. So those are our 3 rules. If I'm having a list, I simply add my exponents together. So like m to the 5th plus m to the 6th, so all together m to the 11th. If there's an exponent, I need to multiply them. So I have groups of m to the 3rd. So I took 3 times 2 to get that m to the 6th.